Hi, hello everyone. This is Dr. Chiranjeevi Manike, Professor and Head of Data Science and Cybersecurity Department, MLR Institute of Technology, Hyderabad. As part of data mining video lecture series, in this lecture we are going to discuss another very important concept in data mining, that is outlier analysis. So here we are going to explore what are the outliers and what are the different types of outliers, and then we'll see the challenges of outlier detection. So let us see what is an outlier. As I said many times, outlier is an extreme value. Is data out, as per the definition, the outlier is a data object that deviates significantly from the set of the objects as if it were generated by a different mechanism. So outliers are different from the noisy data. Noise is different, outlier is different. Noise could be like, suppose if the data set is being prepared by, or some particular values would be entered by the humans, and there would be a chances to get the noisy data. So, but the outliers are different from the noise. That we will understand in the coming slides. So outliers are interesting because they are suspected of not being generated by some mechanism as rest of the data. Therefore, in outlier detection, it is important to justify why the outliers detected or are generated by some other mechanisms. So outlier detection is also related to the novelty detection, that is mainly in involving the data sets. Like suppose if in online social media websites, if any new topic popping up, and that would be considered as a novelty detection. But the difference between this is, once we identify this novelty, and the subsequent information would not be considered as a outliers. So there are the different types of outliers. Mainly there are three categories: global outliers, contextual or the conditional outliers, and the collective outliers. Let us see one by one. So let us see what is global outliers. In a given data set, object is a global outlier if it deviates significantly from the rest of the data set. So from this diagram you can see, and these data points, these are completely away from these data points. So these are completely deviating from the rest of the data points. The global outliers are sometimes called as point anomalies and are the simplest types of outliers. Most outlier detection methods are aimed at finding this kind of outliers, that is global outliers. So to detect the global outliers, a critical issue is to find an appropriate measurement of deviation. How, like, which measurement we are going to use to find out how the deviation, that is deviation with respect to the application into the question. So various measurements are proposed, and based on these outlier detection methods are partitioned into the different categories. So next one is contextual outliers or the conditional outliers. So in a given data set, a data object is a contextual outlier if it deviates significantly with respect to a specific context of the object. So in this case, so contextual outliers are also known as a conditional outliers because they are conditional on the selected context. Therefore, in the contextual outlier detection, the context has to be specified as a part of the problem definition. So these generally in a contextual outlier detection, the attribute of the data objects questions are divided into mainly the two types. That is, contextual attributes and behavioral attributes. The contextual attributes of a data object defines the object's context. For example, the temperature example, like the contextual attributes may be date and location. I think I forgot to mention this example. So let us correlate this. I forgot to mention this example here. So let us take a city. Let us say city A, and the winter temperatures, like suppose some 8 degrees Celsius, or let us say 8 to 10 degrees Celsius. That is during winter, the city temperatures would be in the range of 8 to 10 degrees Celsius. The summer, this is winter, whereas in the summer, temperatures from 30 to 45 degrees, 30 degrees Celsius to 45 degrees Celsius. Let us understand and just assume to understand what do you mean by this contextual. So here, like suppose this is like the data, like a winter in a city, the temperatures in the winter drop to even 8 degrees, the minimum, and the max 10 degrees. That is, and whereas in the summer 30 to 45 degrees Celsius. Suppose if a value, like suppose if you have collected the temperature data from this city for entire year or like first few years data, in that one data point or a tuple is having a temperature, that is a temperature, summer temperature. Okay, the summer temperature is some 40 degrees Celsius. Okay, so in that case, and it would be considered as an outlier. It would be considered as an outlier. That is in the global outlier case. If you plot this data, then this value, like suppose if you compare, if you have collected all the winter temperatures, and if there is a value like a 40 degrees Celsius temperature, then this value is significantly deviates from the rest of the objects. And similarly, if you select if there is a value like 8 degrees and the rest of all the data points having the temperature ranges like 30 to 45 degrees, so then that would be considered as a noise or an outlier. So in this case, by using this contextual outliers, how this would be interpreted? The contextual, because it depends on the contextual attributes and also the behavioral attributes. So the contextual attributes of the data objects defines the object's context. Okay, but because here the temperature, the winter temperatures are like 8 degrees to the 10 degrees. Okay, but if you have collected the temperature, all the if you have collected the entire year temperatures, so then the few data points, few temperatures would be very low and few temperatures are very high, like that. So then, so this would not be considered as an outlier, or even this also would not be considered as an outliers. So the contextual attributes may be here in this case, for this example, the date and the locations. So next, another one is a behavioral attribute. That is, these defines the object's characteristics and are mainly used to evaluate whether the object is an outlier in the context to which it belongs. So you have to recall this example again. So in this temperature example, the behavioral attributes may be the temperature, humidity, and pressure. So unlike the global outlier detections, in contextual outlier detections, whether a data object is an outlier depends on, here in this case, it's a context, right? So winter, the temperatures are like 8 degrees to 10 degrees, whereas the summer, the temperatures would be 30 degrees Celsius to the 45 degrees Celsius. So this is depends on the context. Coming to this detection, like how this contextual outliers or conditional outliers would be detected. Unlike the global outlier detections, in the contextual outlier detection, so whether a data object is an outlier depends not only on the behavioral attributes but also on the contextual attributes. A configuration of a behavioral attribute values may be considered as an outlier in one context. For example, like this is another example you will get from the textbook, that is 28 degrees Celsius is an outlier for a Toronto winter, because The winter, the temperatures would be very small, very low, but its temperatures is a normal day temperature. So then this would be considered as an outlier in the context of this example. But an outlier in the another context, that is 28 degrees Celsius, not an outlier for a Toronto summer. The same data point, that is 28 degrees Celsius, that would not be an outlier for another context. So contextual outliers are a generalization of a local outliers. So a notation introduced, that is a density based outlier analysis approaches. An object in a data set is a local outlier if its density significantly deviates from the local area in which it occurs. Next, the third category of outliers, like given a data set, a subset of data objects forms a collective outlier if the objects as a whole deviate significantly from the entire data set. Importantly, the individual data objects may not be outliers. So like for example, let us say there's the group of objects belong here are situated, and there are a small group, okay, small group. So in that case, and this is used to call it as a collective outlier. That means the whole objects, the group of objects deviate significantly from the entire data set. This is an entire data set, and this is these are the group of objects deviate significantly. So you can also understand from this one. So this diagram, from this diagram you can observe like all the rest of all the data points except this are normally distributed, uniformly distributed. But whereas the data points in this region are very close, very densely populated, so then that would be considered as a collective outlier. This is another category of outliers. So unlike a global or a contextual outlier detections, in collective outlier detection, we have to consider not only the behavior of individual objects but also that of groups of objects. So therefore, to detect the collective outliers, we need a background knowledge of the relationship among the objects, such as distance, similarity measurements between the objects. So a data set can have multiple types of outliers. Moreover, the object may belong to more than one type of outlier, like it could be a global outlier or contextual outlier or any kind. So in business, different outliers may be used in various applications or for the different purposes. So global outlier detection is the simplest one. Contextual outliers require the background information to determine the contextual attributes and context. Whereas contextual outlier detection requires a background information to model the relationship among the objects to find the groups of outliers. So there are different challenges of outlier detection, like modeling the normal objects and the outliers effectively, application-specific outlier detections, handling the noise in outlier detection, and understandability. Let us see in detail each challenge. So modeling normal objects and outliers effectively. So outlier detection quality highly depends on the modeling of a normal, that is non-outlier objects and the outliers. How we are going to model it? So building a comprehensive model for data normality is very challenging. So that is, if you are able to build a comprehensive model, so then it would be very easy to detect the outliers. So it is hard to enumerate all possible normal behaviors in an application. So the border between the data normality and the abnormality, outliers, is often not clear cut. So outlier detection methods assign to each object in the input data set a label of either normal or outliers. And some other methods would assign each object a score that is measuring the outlierness of the object. So few methods give the labels and few methods gives the score as a measuring score, that is outlierness of the objects. And another challenge is application specific outlier detection. Technically, choosing the similarity or the distance measures and the relationship model to describe data objects is critical in outlier detection. Unfortunately, such choices are often application dependent. So we cannot use the same methods for each application. Different applications may have the different requirements. For example, in a clinical data analysis, a small deviation may be very important enough to justify an outlier, that is in clinical. But in contrast, marketing analysis, objects are often subject to the large fluctuations and consequently, a substantially large deviations is needed to justify an outlier. So outlier detections hide dependence on the application type. It makes impossible to develop universally applicable outlier detection methods. Instead, individual outlier detection methods that are dedicated to the specific applications must be developed, because the same method cannot be used for each application. Next, handling noise in outlier detection is another challenge. So noise often unavoidably exists in the data collected in many applications. So noise may be present as deviations in attribute values or as even missing values. But low data quality and the presence of noise brings the huge challenge to outlier detection. It is very difficult to identify the outliers. Moreover, the noise and missing data may hide outliers and reduce the effectiveness of outlier detection. An outlier detection method may mistakenly identify a noise point as an outlier. Next, the challenge is understandability. In some application scenarios, a user may want to not only detect the outliers but also understand why the detected objects are outliers. We cannot simply if you plot the data and we could not label that a data object because it is deviating, but we need to understand why. So to meet the understandability requirement, an outlier detection method has to provide some justification of the detection. For example, a statistical method can be used to justify the degree to which an object may be an outlier, based on the likelihood that the object was generated by the same mechanism that is generated by the majority of the data. So the smaller likelihood, the more unlikely the object was generated by the same mechanism, and more likely the object is an outlier. Thank you for watching this video. Next we'll discuss some other concepts.